What is the difference between PDV and VDP work? Let's first understand the difference with respect to the system. So in PDV, when we say that PDV work is happening, then it happens only in closed system. It happens only in closed system. That means there is no flow of mass in closed system, and that is where we can say that PDV work is happening, while VDP work happens in open system. Now why is it so? So to understand this, we have here closed system and open system. Now this closed system, you can see we are giving heat to gas, and this gas is continuously expanding. It is increasing its volume, and when what we can see here is there is some change in pressure, and when this pressure is changed or it is increased, the pressure again comes to the steady state from unsteady state. That means when the pressure is increasing, it is utilized into the displacement of piston, and that is how we can say the pressure is constant. The pressure is remaining constant throughout the process while there is some change in volume. So this change in volume is what giving us work in closed system, while when we talk about open system, you can consider a pipe flow due to some pump work. And this, in this open system, you can see that there is an imaginary boundary that we have to create to consider it as a control volume, because we have to somewhere draw the line and study our system. So therefore in open system we draw an imaginary boundary, and inside that we consider as our thermodynamic system. So what happens here, here we have constant volume. This constant volume is here, right? But if you see there is some pump work, and that can happen only due to difference in pressure. So pump work or turbine work can happen only due to some difference in pressure. So here we can say that pressure change in pressure is what giving us work. Therefore volume is constant. Of course we have taken control volume in open system because there is continuous change in mass flow, there is a continuous mass flow, therefore we consider a particular volume which we have to analyze. Next difference we can see on the basis of process. Now the process in PDV work is reversible. And why is it reversible? It is reversible because the pressure is constant at neighboring states. The pressure is, you can see here, this is the piston we have, and this is some, there are molecules of the gases, or there are some particles of the gases that are applying pressure to the piston of the piston cylinder. So what happens, this is there is some displacement, and that displacement is giving us some change in volume. That displacement, if you just see the two neighboring states, the pressure you'll see is somewhere equal, right? It is somewhere equal. The pressure is not changing if you just change if you just see the neighboring states. Therefore we consider it as reversible because it is very slow process. And here you can also take quasi-static process, because quasi-static process is not exactly reversible, but there is some friction or there is some heat dissipation to the surrounding. In VDP work we consider both reversible and adiabatic, right? Reversible will be there, but also it is an adiabatic, therefore there is no heat transfer. So PDV work is plotted like this, and this process is PDV, this process is VDP. You can see the difference how they are plotted. Now we can consider a few examples of the PDV work. See, examples are displacement or expansion or compression works gives us PDV work. So in expansion or compression stroke of the IC engine, both the valves are closed, so there is no mass transfer. Therefore we can say the system we are dealing with is our open system. And when the system is open system, we can say that there is displacement work that we are getting is PDV work, right? Because there is only difference in volume and the pressure is almost constant throughout the process. Now when we talk about VDP work, there are some examples like the turbine work we get, and this pressure difference is what gives us work. So how do we get work? Let's just see here. This is our turbine, and here you can see the entrance of the turbine. There is some area, right? A at entrance, some area at entry, and some area at exit also you can see. So as you go from here to here, you can see there is some decrement in area. Therefore we can say area at entry is more than area at exit. Therefore velocity, if you talk about from continuity equation, even v1 is equal to a to v2, we are considering it for incompressible fluid like water, then we'll be seeing that velocity at exit will be more as per the continuity equation. And as per the Bernoulli equation, then we can see that the entrance will have more pressure than that of exit, right? So therefore we can say that this change in pressure from high to low, the fluid will flow, right? And therefore we get the work done at the shaft of the turbine. So this work is basically due to change in pressure. Now next we can see some examples here, examples of PDB work. What are the examples? Expansion and compression work, right? These are the examples. Expansion happens in IC engine and compression you can see in reciprocating compressor. So these are the examples of the PDB work. And if we talk about VDP work and how we can plot that, you can see here the expansion work that we get in turbine and the compression work that we give in centrifugal pump is VDP work. Next, PDP work is also called non-flow reversible work. As we have said that in PDB we have a closed system, and in closed system there is no flow of mass, therefore we call it as non-flow reversible work. And also the process is somehow reversible, as we are considering the pressure constant between two neighboring states. If we talk about VDP work, then that is our steady flow work, as we have open system in that, and therefore we can say it as steady flow work.